All right, hello everybody, and welcome back to our sixth lesson video. And today we're going to be talking about creating assemblies. I know it's going to be very exciting. I'm excited personally. Just saying that as a personal opinion, but yeah, So today we're going to be getting into some more CAD, and one of the most important things we're going to be learning, which is assemblies, and how to make them, realistic and applicable. So, getting started, right? Assemblies are constrained groups of parts. Basically, assemblies are designed to mimic things in real life. So, if in real life, your drive-based assembly, let's say for your robot, had a frame, like your chassis frame, and then some wheels coming off of it, then that's what you would have in the CAD, and those wheels would be able to spin like they can in real life, right? And then that CAD assembly would be used as a reference to build that actual drive base. So good knowledge of assemblies is super important to a CAD user, right? Being able to create them efficiently and quickly, like you're assembling something in real life, just in your CAD. It's super important to be able to do that, and it's really makes up the majority of robotics CAD work. I mean, robotics CAD work, it's not like a ton of most CAD work, in fact, is not like, the design doesn't happen, like the tricky critical thinking part doesn't happen in the CAD. The CAD is just, going through the steps, going through the motions, going through the busy work to get your design that you thought of and that you put in the work to think of in your head, right? Taking that design and, translating it onto the paper. So yeah, good knowledge of assemblies is super important because the faster or the more practice you have with that, the faster you'll be able to translate that assembly or that design in your head onto the CAD, right? And the faster and more effectively you can do that, the better your designs will become because you can iterate on them and you can give them to others for approval, and you just will generally, like, CAD will become less of a barrier and more of just a translation of your design. That's what CAD should be. It should be a natural translation of the design in your head, and that's, like, nobody's really fully there, but like with a lot of practice you can get closer and closer. All right, so first things first, we're going to learn mates. All right, and so let me get some background here, right? Assemblies, they're not just, groups of parts sort of all floating around and whatnot. They're constrained. And constrained means that they're, held to each other with certain relationships and certain properties. Now, a part has 6 degrees of freedom, so it's going to have movement forward and backward, up and down, in and out, which I can't show on this two-dimensional screen. And it's also going to have roll, right? So it's going to have rotation along each of those 3 axes. So that's 6 degrees of freedom, and those rotations are called pitch, roll, and yaw. But all we need to know, right, is that it's 6 degrees of freedom, so it's 3 degrees of movement, and then this one as well, and then 3 degrees of rotation along those axes of movement. So as we're getting into mates, basically what mates do is they take these points called mate connectors. And mate connectors is basically, a mate connector is a point that Onshape decides, or that you can choose on your part. A mate connector is a point, and it has 3 axes, and you can connect it to another mate connector and give them different restrictions between degrees of freedom. So you can say this mate connector and this mate connector are completely fixed together, so there's no degrees of freedom between them. Or you can say this mate connector and this mate connector are rotational to each other. So one is fixed and the other one could rotate about one axis, let's say. And there's all different sorts of mates that can give you different types of degrees of freedom. So the first thing we're going to be doing is using a little bit more of an abstract assembly, right? This Arbor press assembly here. And we're literally just going to be going through and using different types of mates. And the most common types of mates we're going to be using are fastened mates, which restrict all degrees of freedom between 2 parts, and revolute mates, which allow for a rotation. So we'll go to our Onshape here, and we'll go to this right here, Arbor Press Practice Assembly, and we'll right-click it, and we'll say Copy Workspace. Now, if you're following along at home, if you just go here to Public and you search Arbor Press Assembly, then there are many results that are there that will look like this, and you can just make a copy of one of them and follow along that way. But yeah, we'll go ahead and say Copy Workspace, and we'll name it our name. All right, we'll name it our name. And now we'll go back here really quick and just make sure it's in the right spot, right? So this is ours. We'll move it to team member folders, and we'll move it to my folder here. right? Move that there. All right, so now we're going to go ahead and go back to my folder here and here, and we're going to click this, and we're going to move it forward. You can see I've already done it a few times, but yeah, we'll move it forward here, and there we are. All right, so what we're going to be doing, right, and we've got this this reference here, is what we'll be doing, and we've got so we've got this assembly here, right, which I believe has been constrained, right. This one's been constrained properly, so you can see that, and we'll use this as a reference, so you can see that, you know, an Arbor press basically is a tool that squishes stuff. So what you've got here is you've got a rack and pinion. Go ahead and hide this. You've got a rack and pinion, so when you push this down, it's going to fit in those notches, and it's going to spin this, right? It's going to fit in those notches and spin that. And when you spin this, it's going to do the same thing, right? So we'll unhide that, right? Click the little thing there, and there we go. So we're going to make a new assembly. Go plus here, and we'll say create assembly. And we're going to name it, we'll name it Arbor Press Practice. That's what we'll name it, all right? And now what you've got to do, the first step of making an assembly is inserting parts. You can also insert assemblies, but typically we'll just be inserting parts. So you can see here, this Arbor Press Part Studio, right? This is a part studio, this is not an assembly. This is an example of a multi-part part studio where you can make multiple things in one part studio. So each one of these is an individual part. You can see they're all named, right? They're named differently, named by the creator of this document. I did not make this document. This was made by somebody else, but it is typically what's used to showcase assembly mates, right? So you've got all these different parts, and when you insert this part studio into the assembly, they will be free moving, right? But right now they're all just fixed together because that's where they were made. All right, so we'll go ahead and go to our assembly, and we'll go insert. And then you can see here you actually have current document and other documents, as well as standard content. Other documents and standard content you don't really need to worry about. Other documents, basically you can take parts and assemblies out of other documents in Onshape and insert them into your assembly, which is actually really, really useful, especially if you're just trying to use that for, I don't know, let's say like you have like, you know, a CAD that you did of something, and you want to take like a few parts out of that and put it in, you know, another CAD. You don't have to worry about downloading those onto your computer and then importing them into this assembly. You can just, you know, take them from one and put them in the other. And then if you change them in that other one, they will change in both. But yeah, so we've got part studios and assemblies, right? So we're just going to go ahead and insert this Arbor Press Part Studio. You can see we have all these parts here. We'll just insert this top one, this Arbor Press here. Actually, no, you know what? We're going to insert all of these. So we'll insert the base here. We'll insert this bushing, which will go over here. We'll insert this cover plate, which will go here. And we'll insert this crank, which will go right here. And we'll insert this handle, which will go on the crank. And then we'll insert this rack, which is like what actually gets pushed, which pushes down. And then there's also this little table here. And there's some bolts and fasteners down there. We don't really care about those. So we'll insert that, right? And now we've got our assembly, right? Nothing is constrained. If you click and drag something, it'll move around. So the first thing we're going to need to do because of that is move this central thing into the right spot. So I'm just going to move it up here so that the origin of the assembly is just about below there. It's just kind of arbitrary, but it's where I like it. That way, if you look from the front, actually no, we want to rotate this 90 degrees because if you look at it from the front, it should appear to be from the front, right? So we'll rotate this. Now, in Onshape, you can highlight two different ways, right? So if you do yellow highlight, which is to the left, if you do yellow highlight, it'll select anything that's even partially contained in the highlight box, right? So if you select this and then even just a little bit of this, it'll select them all. If you do blue highlight, it'll select only something that's completely contained in the highlight window. So only this box here. And that's really useful, right? If you're trying to highlight only these things, but you can't really fit that, then it'll only highlight these things. And you can't actually deselect things unless you go over here. You can also just select things here and do it that way. But yeah, so highlights are important to know. So what we're going to do, we're going to highlight everything. and we're going to rotate it because we want it to be rotated 90 degrees so that the front is in front. And that's just a personal preference for me. Say 90 there, use that little rotation thing, 90 and enter, and it'll rotate us 90 degrees, and then we'll move it to where we want it to be, right, which is like right about there. All right, right about there. And now this is in the right place, right? Maybe we'll move it a little bit this way, so it's just in a little bit. Again, I'm a little bit, compulsive about these things, but you gotta have your guilty pleasures. So now we're gonna click this, right? We're gonna right-click it, and we're gonna say fix, because right now, when it's not fixed, you can just drag it and move it around, right? But if you, let's say, had a rotation in here, like this was stuck in there and rotating, if you wanted to rotate this by dragging it and moving it around, it would just move the whole thing around instead of getting the rotation you wanted, even if everything was constrained. So what we're going to have to do is fix it. So we'll unfix that, and I'll just show you, right? You could just move this around, and if you had something inside of this, it would just still move around. So we'll press Control-Z to undo that movement there, and we'll right-click this and say Fix. And now if I try to click and drag it, see there's a little fixed icon that comes up, so we cannot move it, it's not going anywhere. And you always have to have a fixed component in assembly, and it usually makes sense to make it, something that's rational to have be fixed, like maybe a base plate like this, or like the rear rail of your drive base, or something like that. So now we're going to get into mates, right? And you'll see what I was talking about earlier with mate connectors in a few minutes, but let's start with our basic mates that we have. All right, the most two common we're going to be using are a fastened mate here, which restricts all degrees of freedom between two parts. And then we also have our revolute mate, which restricts all degrees of freedom except for rotation about the axis of mate about which the mate has been created. So we're going to click our fastened mate first because we want to attach this cover right here to these holes here, and you would have bolts that sit in there and go in these holes, right? But we won't have those bolts in the CAD for now. So yeah, we've got those bolts there. So we're gonna go ahead and click our fasten mate, or if you're a gamer, you can just press M. We'll click our fasten mate. Apparently I'm not a gamer because I just pressed that. But yeah, we'll click our fasten mate and we'll click the hole we want to add. And you can see Onshape sort of, many other CAD softwares just use the existing geometry like, edges or points, vertices or faces. But Onshape, and with that type of assembly model, it works pretty well, but you have to do a lot more mates in order to get the same sort of connection. So with Onshape, you only really have to do one to get a connection, and that's really useful. So we're going to start. I'm going to click this, right? And Onshape is going to pick, it'll pick the center points of faces. It'll also pick the center points of lines, as well as the end points of lines. It'll pick the end points of arcs, the center points of those arcs, which happens to be on the middle of that circle there. But that circle could also be independently chosen, right? And it'll also pick corners there. And then if you go on this face, it'll do the same thing. See? So it's not too complicated. It's when you start getting into complex features that it actually, like complex surfaces and parts, that it does get a little bit more confusing. But even then, it's not really that confusing. So we're going to select this circle. We're going to click that. And then we're going to click the corresponding circle that it would be mounted close to. Click there. And now it's fastened. Easy as that. If you press this one, you'll be able to do another mate. It'll prompt you to do that. But if you click up here, it'll end the operation, right? So now if we drag this, it's not going anywhere because it's fixed to this fixed component. So it's fastened to this component, which is fixed, right? We can't move it. So by proxy, this won't be able to move. Now, you can also do something like an offset here, which is where you would change basically the motion along the axes. You can also do rotations around the three axes. Like I was talking about, you have 1, 2, 3, 4, 5. That was not good counting. 1, 2, 3, 4, 5, 6 degrees of freedom, right? So we'll go ahead and change this x-axis just to showcase here. It's in millimeters. I don't know why it's kind of scary. I don't like millimeters, but we'll move it over 10 millimeters, right? Just to showcase this. And that'll move it 10 millimeters along this x-axis here, right? 10 mil. And if we try -10, it'll go the other way. That's -100. -10, it'll go the other way, right? And if you just say 0, it won't go any way at all. So we'll go ahead and uncheck this offset window, but just know that offsets can be quite useful, especially if your mate connectors don't line up quite perfectly, but usually they will because you'll have holes that will go together like this, or some sort of surface that would be glued or welded, or something like that. So now we'll go ahead and check this box here, and we're going to have to do another fasten mate because we have this bushing, which is just like a piece of slippery plastic that allows something to rotate and slide within it. This bushing has to go in this hole here, right? And you can see that because this bushing winds up going around the edge of this pin, or this pin rather sticks into the bushing, and you can see that, you know, it's actually raised up around here, so it's going to be on this side here. And this bushing, if you wanted to check the outer diameter of this, it's going to say 19.05, and the outer diameter of this will likely be around 19. Oh, it's going to be 12. Oh wait, no, I picked the wrong one. That's 12, and then it's going to have to be the inner diameter here that matters, right? 12. It's again the same. There's going to be like 0.2, I believe, of clearance there, right? 0.7 and 0.7. No, they're the same. Okay, but yeah, so they're going to be the same diameter, and that's always a good way to check. So now we're going to press M because we're gamers, or you could just go up and click here, and we're going to select the front face of this. There's many ways to do it. You could select this line, or this front face. They all give you the same point, right? They all give you the center line up here. You can also click any of these three. With the cylinder, it'll give you the center point and end points of the cylinder. So you could like do this one and offset it however far it is away, or do the center even, and figure out some way to offset that. The most simple way is just to click this, right? And then click the front face here. And it's going to bring that up there and fasten it. All right, so those are all the fasten mates we're going to be using. No, I lied. Never mind. We have one more. All right, we have one more fasten mate. And that's this one. And you can see that there are, you know, a few more points to choose from here, and that's just going to be the same thing, right? Edges of lines, edges of curves, center points of curves, cylinders, all three parts of a cylinder, centers of curves again, and centers of lines, right? And then the center of the whole face as well, and this, which happens, actually the center of the hole doesn't align with the center of the face. We can go ahead and click this and drag it away so we can see it a little bit better. Because you can't do that if you click and drag, it won't set a mate connector. But you can see that the center of the face is not completely aligned with the center of the hole. And usually it will give you a little checkerboard, see, a little checkerboard there for the center right there, if you can see it. I was pointing at my screen, but you guys can't see that because this is just a screen recording. But we'll go ahead and click this hole. Actually, we got to click the hole on the underside. We'll click this hole on the underside here, right? Because that's the one that will correspond to the hole that we want to mate it to. So you guys go ahead and look at that. Right, this hole right here will mate to that one. So we're going to go, we'll click this one. And we'll go in and we'll click this one. Right, these are our 2 points that we're going to be mating. It would probably, again, just be a bolt through there. We got to zoom in a little bit to make sure we got the right one. And that's going to move it up to here. And you can see also in this mate dialog window, there's a few more ways to change your orientation. So you can change your secondary axes, which are your X and Y, right? If you click that, it's going to flip 90 degrees each time you click it until it comes back around. And then you also have your flipping your primary axis, which is going to be your Z axis here. So if you click that, it's going to flip, right? Just like that. So if you wanted to select the top, mount it, mate it to here, and then flip it, you could have. That's a feasible thing to do. But we selected the bottom anyway, right? The points that connected. You could also offset it as well. And you can see here that we have our mate connectors. You can always get rid of one, right? If we wanted to delete this, we could see that this is now free to move around. So if we went ahead and clicked this one, right, and then this one. Oh wait, we clicked the wrong thing. If we went ahead and clicked like this one and this one, you can see it would go like that. If we just reorient the secondary axis, it will go up there, and that's pretty good. And you can always, you know, X out your mates there pretty easily. So yeah, we'll go ahead and make a check mark there, and that's going to be our last fasten mate. Now, we're going to move on to some more mates now. And the first thing we're going to do is insert this little pin here, right? This little pin has to go in this hole. So now we're going to use something called a revolute mate, which allows for no degrees of freedom except for rotation. So we'll go up here, press revolute, and it says you can press M there to get the shortcut. Usually when I press M, it just gives me the fasten mate. Actually, that always happens. So I'm not sure entirely what Onshape means there. Again, here we can see again there's another example where if you can click different options to get the same point. That's often the case with Onshape mate connectors. But it's better to have it be redundant than to have points that you can't reach. But yeah, so we'll go ahead and select this outside edge. Actually, we'll select the inside edge because that's actually what's going to be riding on the inside here. Doesn't actually matter, but you know, I think it makes a little bit more sense. So we'll click this, which it would correspond to, and we'll click check. And that's going to give us revolution between there. All right, that's going to give us revolution. So now if we click this and drag it, it's going to spin, right? That's a revolute mate. It's as simple as that, and it's actually pretty effective. But now we need to constrain this handle to this thing. So we're going to use another fasten mate. We could also use a slider mate, right, so that it can slide back and forth. But here, I'll show you how a slider mate works really quick. So if we go ahead and click the center point of this cylinder, and then we can also go in here and find the center point of that cylinder. And they would mate together, and you can see that you'll be able to slide it, as well as, but the problem with that is that you can't really rotate it that well, right? If you pick it and click it, it won't really do anything but slide, and you can actually see it will slide farther than that. So you can, if you go ahead and double click on that slider to edit it, as a rule, as I said before, you know, if you double click on anything in Onshape, you will be able to edit it. You could offset this or give it limits, right? So you could give it a limit so that it can't travel so far. And then you can animate the degrees of freedom like that. You can animate the degrees of, and that you can see that that animation goes farther. But we don't want to give it any limits because we're actually not going to make it a slider mate. We're going to make it a fastened mate right here. So you can change the type of mate here, right? It's still mate connectors, so it's just going to be different rules applying between them. So a fasten mate like this, you can see now, if you click it and drag it, it will just spin like it's supposed to. And if you spin that, you can see that the inside of this little thing here is spinning, right? You spin that, see that that's also spinning as well. Awesome, 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 awesome. So now, what we've got to do is constrain this last mate, which is this thing sliding in here. Right, this is going to be our last mate, and what we're going to do is we're going to go for a slider mate, I believe. We can do a slider mate. And that slider mate is going to be, let's see. I think we'll want this slider mate to be between this mate connector here, right? Because we want the main axis to be pointing up because that's where it's sliding. So the main axis being the Z axis here. So we want that to be there, and then we'll pick something pointing up here as well in the center. So we'll click that, right? Now they're going to be here, just like that, and it's constrained how we like, how we want it to be, right? And strategically picking where your mate connectors come from is pretty important. You can see this is at the bottom of the range of travel, so we can go ahead and slide this on up, but you can see it will also slide past where it's supposed to, right? In assemblies, it sort of ignores physical contact, and you can actually run interference detection to check if anything would touch. But right now, right, it doesn't. It's better to have it be able to go through just so that you can pick and choose what you want. But if we go here to this slider mate, we'll go ahead and give this one limits, right? We'll give this one limits. So maximum, I think we want our maximum to be like, I don't know how many millimeters is like a good amount to do. Let's try 200 millimeters. And then, no, this is the wrong one. What the heck? Oh no, this is just the, that's just ignoring this, right? If we go ahead and flip these upside down, that should solve the problem there. And that's just the order in which you mated these. It will ignore other mates and it will just move this one up and down. So now this should move up and down. Yeah, 200 mil seems reasonable. Why don't we go with like 170? 170 seems reasonable. Yeah, I think that's good. I think that's good. All right, and the minimum there, right? But the problem is it can still go past here, which we don't want. We don't want that. We want it to be only be able to go like about this far. So we'll make the minimum like -10, right? And that'll put it up 10 millimeters. Now let's try animating those degrees of freedom. Let's see what it looks like. Oh, see, now it's just going to be able to go -10 millimeters down. I think we need that to be +10. A lot of the +10. A lot of this is just trial and error. But that's a lot of what CAD is. And the more you do it, the more in tune you get to how it works. So now we have these limits set, and this should be able to move properly. But now we have this problem, right, where when we move this properly, that's fine. We can also move this properly. But in real life, right, when you spin this, it'll move this up and down. So now we're going to use something called a relation. Now what a relation does is it's basically a mate between two mates. So a gear relation is going to give you a relationship between the motion of two revolute mates. A rack and pinion relation, which is what we're going to be using today, is going to give you a relationship between a revolute mate and a slider mate. A screw relation is going to give you a relationship between another revolute mate and a slider mate, but it's going to be in a different direction, I believe. Or it might be between a revolute mate and a cylindrical mate, actually. That's a possibility. And then a linear relation is just going to be you move something up, another thing moves up with it, maybe at you know, it's going to be between two slider mates, actually. So yeah. All right, so first things first, let's open up our relation, rack and pinion relation dialog window, because this is a rack and pinion, right? This is a rack, and this thing here is a pinion, right there. It's an opinion. But yeah, so rack and pinion right there. So we're going to pick our mates, and if you just sort of hover over different ones, you'll be able to see which one's which, you know. So we'll go for our revolute mate here, it's the only one, and our slider mate, it's also the only one. Distance per revolution, I'm not sure what that should be, so that's another thing we'll have to find through trial and error. And you can see here this looks pretty good, right? When you rotate it this way, it's going to move up. When you rotate it the other way, it's going to move down. Reversing the direction would change that, right? So when you rotate it this way, it's going to move down, and vice versa. But we don't need to reverse the direction. We'll just try it as is. Now, if it feels too slow, we'll go ahead and change. That is wrong. I guess we did need to reverse the direction. And a lot of these things, you know, there are rules for them, but sometimes it's easier just to figure them out through trial and error. So this feels a little bit slow, right? I'm thinking it should be a little bit faster. And if we go ahead and we hide this, even if you hide it, it's still like there in quotation marks. We'll go ahead and hide this, and we'll see how yeah, see, look, these are spinning faster than the rack is moving through, and we're not going to get it perfectly accurate. We won't. But I think we'll go ahead and try to make it a little bit closer. So maybe distance per revolution, we'll change that to 50. Right, that'll make it twice as fast. And if we go ahead and click on this revolute mate, and we click animate, and we make it play. That's interesting. We may have just, oh wait, we may have just, let's see if we go to this revolute, and we animate this. That's interesting. Sometimes it really doesn't like to cooperate, but there may be a valid reason. I'm genuinely unsure here. Yeah, okay. All right. I don't think we'll be mating that, but why don't we just try spinning it, right? Just to test and see if 50 seems fast enough. I think that seems a pretty decent speed. Maybe we should make it a little bit faster, or maybe we should make it slower. What do you guys think? No, that seems pretty reasonable, actually. They look like they're meshing pretty solidly. They might not be perfectly on target, but they look like it looks about right, right? So we'll go ahead and unhide this, and there we go. We have a completed Arbor press assembly, right? It's constrained to look like real life and to look normal, right? So we'll grab this lever, spin it around, right, and that'll give us motion there. And sometimes it takes a second to compute, but if you keep doing spinning like that, it will give you motion in the other direction. Especially if you have a bunch of mates related together. But okay, yeah, so now that we've covered our basic mates, we're going to be covering something that's a little bit more applicable, a little bit more relevant, all right? A little bit more relevant and a little bit more applicable. So we've done that. Right, now we're going to do a pretty simple assembly, but this is something that is a little bit more relevant to robotics and practical design, right? We're going to be using parts that we can download online, and we're going to be using these parts in order to make an assembly, right? In order to make an assembly that we would actually use on the robot. This looks pretty similar to the corner of our robot, of our drive base, right? It's sort of these VersaFrame pieces, and they're connected on a right angle by these gussets, right? And then these bolts go down through these gussets here, and then these nuts tighten down onto the bolts, and the whole thing is held together. But what we're going to do, and I wanted to do something special for this, right? So the first things first, let's just go back to our Onshape here, and let's go ahead and go back to off-season 2020, and we'll go to presented practice documents. And now we have this right angle joint practice. And if you're following along from home, you may not be able to do this, but actually you will be, because we're not going to be just using what's in the document. We're going to be making our own stuff. So we're going to copy this workspace, and we're going to name it our name, right? And then before it opens, we're going to go ahead and move that to our folder, right? We're going to move that to our folder. Move to team member folders. Move here. All right, we've moved that there. Now we'll go back to off season, and we'll go to team member folders, and we'll open up our folder right there, right? You can see we've got a few things, but one of the things that we have is our document. Actually, we may not have imported it properly. It may be, yeah, it is, okay. Wait, where did it go? Did I not move it to the proper location? Let's find this real quick. It has been completely lost, I'm afraid to say. Here we go. I found it. Never mind. So yeah, today we made this, and we're going to go ahead and open it up. All right, right angle joint practice. So you can see we have here, right, this has already been set up for us, and that's kind of cringe. Also, if you're at home and you're following along, you won't be able to do this, right, because it's already been done for you. So what we're going to do is we're going to download all of these things, okay? And the locations for each of these things will be Vex Pro for the VersaFrame and the Gussets, because they're robotics specific, and then McMaster Carr, which is the hardware store I was talking about, for these bolts and these nuts. And I believe these are 832s. We can go ahead and check the diameter there. The diameter is 0.19, which is actually 3/16, so this is a 1032. Size 1032 meaning it's a size 10 in diameter, which is 3/16 of an inch, and then 32 meaning it has 32 threads per inch. So an 832 is actually, it's not 3/16, it's 5/32. So we'll go ahead, and a 3/16 is 0.188 inches, by the way. But yeah, or 0.1875. But yeah, we have this, but we don't want this. We don't care about this. If we look at our assembled reference, this is what we've got to make. So here we have, right, 5 bolts, 5 nuts, 2 pieces of VersaFrame, and 2 gussets. All right, that seems like a pretty easy shopping list, right? And you can see how these are held, right? The bolts just kind of go through the holes and make a sandwich out of it. So first things first, let's find our VersaFrame. Let's go to Vex Pro. I have it bookmarked. Again, I'm a gamer, as evidenced by having Vex Pro bookmarked on my computer. And we'll go here to VersaFrame, and we'll pick out VersaFrame stock. Oh, dang. Oh, man. See, it doesn't open the pop-down menu soon enough. So when you go ahead and hover over it, you want to click it because it's not opening. And then when you click it, it just, everything goes downtown. Everything goes downhill after that. But yeah, so we've got this 2x1 VersaFrame we're going to need, right? That's here, 2x1 VersaFrame. And this appears to have a 0.1 wall thickness. If we look at the distance between these, it's going to be 0.1. All right, so 0.1 wall thickness, that's pretty good. So we're going to be looking for that part in our parts list there, and we'll be modifying it to these lengths here. But first things first, we've got to find the part. So we'll go down here and we'll go CAD files, and we'll go 1x2x0.1 VersaFrame. And this is aluminum VersaFrame tube stock, right? 1x2x0.1 means 1 inch by 2 inch by 0.1 inch wall thickness and 59 inches long. So let's check this out. Do you think this looks the same? I think this looks the same, right? That looks pretty much the same as what we've got here. Yeah, it does. All right. So we'll download that part. All right, we'll go here and we will download this part right here. This one. This is the one we're on. So you can see it's going to download down here, and we're not going to do anything with this yet. And now we're going to go up here, and we're going to find our gussets. Now these look like regular L gussets, right? Look like regular L gussets. So we'll go ahead and look for VersaFrame L gussets. These are a VersaFrame specific part. So we'll go up here, and we'll go VersaFrame. We'll go VersaFrame gussets and mounts. You could also just look up L gusset here, right? And that's going to give you the same product window. First frame gussets and mounts. Let's see if we've got the one that we want in here somewhere. Got a plus gusset. Got an angle gusset. Let's see. Do we have the proper gusset that we want? It's possible that we don't. Let's see what the Versa chassis gusset looks like. See, this is a T gusset. We don't want a T gusset. We want an L gusset. There's another VersaFrame T gusset, like this. The plus gusset. We'll look for maybe it's this VersaFrame corner gusset. No, that's not it. All right, so let's go ahead and we'll look for L gusset. And we may have to find this actually from a separate company. Yeah, I think we may have to. So let's go and look for another store that will have this. All right. Well, actually, let's go for gussets. This may be. Yeah, it's possible that this is not what we want. Yeah, it doesn't have. Let's check. Let's preview our 90-degree gusset. See what's up with that. Yeah, no, that's not even close to what we have here. All right. So let's go ahead and look for another store, right, that will have this. So let's try Andy Mark, right? I also have Andy Mark bookmarked, and we'll look up L gusset. I have these sites bookmarked just because I use them not super frequently, but frequently enough to warrant having them bookmarked. So we could use this 90-degree gusset. That's a possibility. Could also use this one, but it's got this little lip thing in the middle. Let's see what we can't find here. I think that may have been the most accurate one. Let's go ahead and view this. Let's also go to ThriftyBot. ThriftyBot, and that's another store for robotic stuff. And we'll look up L gusset. This may be not the correct thing. Let's try ThriftyBot. It may be called the ThriftyBot. Yes, it is. It's called the ThriftyBot. All right, so it's the ThriftyBot, and we'll go to our store, right, and we'll find L gusset. Okay, L gusset. Yeah, so I think we're gonna have the gusset that we're gonna be wanting here, right? And let's see if they have a CAD file, right? This aluminum L gusset here. Let's see if they have a CAD file. Yep, CAD model available. Awesome. All right, let's see if it downloads, right? Let's just download this right here. Hopefully, it's not a virus. You got to cross your fingers with that on every download you make online, but especially coming from the ThriftyBot. Although I don't want to disparage the ThriftyBot, they're a really solid company. They're doing some really good stuff for the FRC. So now we've got 2 downloads down here, and we've got to get 2 more, which these are going to be the easy ones. These are going to be the easy ones. It's the nuts and bolts from McMaster Carr. So this appears to be and we'll see what we can't do. Let's measure from here to the end of this bolt just to see how long it is, right? It's a 2.5 inch 1032, right? We know that from the diameter, from the thread count, and from we didn't count the threads, but we're going to assume it's a 32. 1024s are also used, but not by us as much. You can sort of just see by looking at it, right? That looks a little bit more of a fine thread than a 1024, which would have much coarser threading. But yeah, and the bolts are measured from the start of the shaft, not from the end of the head, right? Not from the end of the socket head. So we're going to go here, and we're going to open up McMaster Carr, which I also have bookmarked, because I'm really just a gamer like that. You already know. And we're going to look up 2.5 inch 1032. McMaster is really awesome. If we go here, we click socket head screws, alloy steel socket head screws. It's going to open up the perfect one just for us. So that's going to be, we're going to have different options. We're going to have fully threaded and partially threaded. We only need partially threaded, which means the threads are on the end where you would likely be using it. So we'll scroll down here, right? These are all the different bolts they're going to be having. And if we make it to 1032s, right, you can see this is the size of the bolt, so that's a number 3 with 48 threads per inch. If we scroll down till we get to 10s and 8s. Here's an 832, which is going to be 5/32 in diameter. There's a 1024, which I just talked about. And here we have our 1032. So now we need 2.5 inch. We'll scroll down here, right? Partially threaded is what we're going to want, not fully threaded. So 2.5 inch. And the difference is just, I mean, they will both work, but one's more expensive. And you got to account, take price into account. So you get a package of 25 for $10. That's pretty good. So we'll go to our product detail here. And we'll scroll down. And you can see it's got all this information about it, and it's got some description there. So here's a little drawing, right? A little two-dimensional drawing here that we could download as well. But we'll just go into this file format here, and we want 3D step, right? We want 3D step. And there's also other formats, but we want 3D step, and we'll go ahead and save that to our computer. All right, now we need our last thing, which is a nut. So we're going to go here, and we're going to look up 1032 nut. And that's going to give us our hex nuts. And we'll go low strength steel hex nuts, 1032. We'll open up that product detail, and we'll go ahead and save this. And because McMaster Carr is also an online store, right, you can add these to your order and to your CAD on one page, which I think is really, really cool. I guess, next time I say something is really, really cool, now you'll have a sense of relativity for what I think is something that's cool. But yeah, so now we'll open up our, actually, first thing we're going to do is import all of these. And you guys won't be able to see my file explorer here, but I'm importing all 4 of these things I just downloaded. All right, so you have the VersaFrame, and we can import them to this document or combine them to a single part studio. We're going to just import them to this document. They'll go in the folder called CAD imports, right? And it's going to upload all of these, and it'll show you the progress. But yeah, so we imported our VersaFrame, which is going to be up here, our L gusset, our socket head screw, right? And also our hex nut. Socket head screw means that the place that you tighten it is inside, not outside. It's not like a hex on the outside. All right, so now they should all be imported except for the VersaFrame. So we'll go ahead and X this out. And we can close all these tabs as well. Actually, we'll leave the tabs open for now. All right, and we'll delete all these notifications. And we'll move these all to imported parts, right? We don't need to edit these at all. Actually, we will need to edit them, but we can do that in a second in a different way. All right, so we'll move these to imported parts, and if you wanted, you could go into imported parts and make another folder called hardware. That's what I would do. So yeah, we'll go ahead and do that. So now we're going to make a new assembly, right? Going to make a new assembly. No, not import. That's the wrong thing. I clicked the wrong button, you guys. Don't worry, don't freak out. We're going to click Create Assembly, and we're going to call it assemble, or no, right angle joint assembly from scratch. Like Bojangles made from scratch biscuits. Exactly like that, in fact. And we're going to go ahead and go to Insert, right? And we've got these things that we just inserted into our document, and this is going to be one of them, right? Our 1x2 by 0.1 VersaFrame. You can see we have a shorter one here, and that's going to be literally the same part that we just shortened and used for one of these assemblies here, right? We used that for both of them, all right? So now we're going to go ahead and insert that, which is going to be long, right? It's going to be long. We're going to have to shorten it. And then we're going to insert some of these nuts. We'll just insert one for now. And we're going to insert some of these bolts that we downloaded here. I believe they're the same. Yeah, I think they should be the same. And then we're going to insert our gussets, which are down here. Right, they're down here. Okay, cool. So now we've got all the things we'll need to build our assembly. First things first, though, we got to fix this part. Let's fix it. And now we've got to make it shorter. So how do we make it shorter? How have we done that in the past? Well, we've got to extrude it, but you can't. So there's no extrude button up here. So what we've got to do is edit this part studio itself. So we could go through here, and we could go to imported parts, and we could find, it's not this one, it's not this one. Is it this one? No, that's just a step file. It's not this one. It's not this one either because that one's shorter. It's not this one. It's going to be this one. We could go through and find that one, but the easier thing to do is just right-click this and say Edit in Context, and that's going to allow you to edit this part studio. See, it went to it automatically. it's going to allow you to edit it in the context of the assembly. All right, so you can see everything else shows up, but it's just a little bit faded out. So first thing we're going to do, and that's what we're going to do, that's what we did before when we did this, we're going to go ahead and create a variable. I'm going to call it length. We'll make it a number. And then we're going to extrude this, which is shifty if you're a gamer, for the gamers out there listening. We're going to click this, and we're going to go remove. And we'll go 59, which we know to be the length, minus hashtag length, right? And this is what we did in our last episode, and that's just going to make it, right now length is 0, so that's going to be 59, which is going to get rid of the whole thing, right? It's going to get rid of the whole thing, but if we go here and we make our length bigger, if we make our length, I don't know, let's say it's 10 for now. So it's 10 for now, it's going to make that 10. So if we go back to our, if we actually X that out, you'll just be left in this part studio, or you could just go back to your assembly by clicking go to assembly. If we go to this, we'll check how long these are. How long are these? Click this line with this thing, and we'll, okay, it's 14 inches. It's good to know. So we'll go back here. Oh dear. I X'd out of the tab there. We'll go back here. Yeah, we'll go back here, back to this assembly here, and we'll make this, we'll go ahead and edit this in context. Edit in context, and we'll make it 14 inches to match. So we're going to change this length variable, 14 inches, right? And the way that's correlated to the length is just by extruding the whole length away, and then basically removing this length from the amount that's taken away, so that gives you this leftover. So we'll go to the assembly. And now I want this to be a little bit centered over the origin, so we're going to go ahead and unfix this and just move it up. We'll just move it up. We'll make it like right here. All right, yeah, that's pretty reasonable. Now we'll fix this component, and we'll go ahead and make a copy of it. So Control C, or you can just right click it and say copy. And then you can right click here and say paste, or you can just say Control V and it'll go where your mouse is, right? We don't need both of these though. We can delete these. And now we got to rotate it 90 degrees. So we'll click this. All right, we'll go over here. We'll go over here and we'll rotate it back 90 degrees, like that. And now we've got to add our gussets and bolts, right? Because this is the assembled reference. This is sort of what it looks like. So we're going to have to add our gussets to both sides, and then we're going to have to add our bolts, and we'll mate everything together. So the first things first, we're going to press M for mate, because we're gamers. And then we're going to go ahead and press the bottom, or select this bottom hole of this first frame here, which will correspond to this top hole right here. And because this is actually an arc, because it's got like this thing, it's not a continuous circle, just select an arc and you'll select the center point there, which is actually inaccurate to the center of the circle itself. No, it's not. Actually, it's the center point of the arc, so it is. It's right on the money there. So it's going to be the center of the hole regardless. So we'll click that, and we'll fasten those together, right? And now we'll open up the dialog window, right? We'll leave that open by checking that check mark, and click that, right, this back hole here, and we'll click this one right here. And that'll move that down and fasten it to there, right? So we've got that. And now we've got to go ahead and Control copy this, right? Control C, just like in Docs, and then Control V to paste another instance. And then we'll go ahead and mate this. We'll mate this right to here. And I'm trying not to, take too long to explain these things, just because we've gone a little bit over time for this video. So I'm just going to try to keep it short and sweet. So now we've got this mate, we've got these two mates, right? And the joint is actually constrained. Everything's constrained properly because it's all connected to this fixed component. But if you did this in real life, it would just fall apart. So you've kind of got to have your hardware. I mean, you don't actually have to have the bolts in the CAD. I often don't use bolts in my CAD because I think they're sort of implied. You can see here it pretty much matches already. But I think the bolts are sort of implied. But in real life, you need them. And so if you were, giving this for assembly, you would also really want to have these bolts. So we're going to go mate. Right, M again, and we're going to click the bottom face of this bolt here. Again, there's multiple ways to get the same point, but we just want the bottom face there. And we'll click one port where the holes go through, so it's not going to be that one, it's just going to be where the holes match up. So we'll click this one for now. Right, and then it's backwards, so we're going to go ahead and flip that. And now we could just copy and paste this and made it to the other 4 holes, but we're going to do something really cool called a replicate feature. And this replicate feature is going to go ahead and let you literally just copy this mate to the other instances. So we're going to click here, click replicate, and then instances. For instances, we'll click this bolt, and then for faces to find match in, we'll click this face. And it's going to do it for all of these, right? We'll need every other one gone, but we don't care because it's much easier to go back and delete them than to have them all, and I'm just highlighting them and pressing backspace, right? Than to actually go ahead and make all of those mates, right? So that's what we're doing. And now we're going to add our nut. Going to add our nut to that, and we could make that a revolute mate. If you wanted to, you could, but really nuts are fastened, and for our purposes in the CAD, it doesn't really matter. We'll just fasten them. So we're going to go ahead and select this face here, and we might have to zoom in on this face just to get the center point is what we're going to be using. So we'll click on that, and we'll go back here. And we're not going to click on any part of the bolt just because the geometry is pretty complicated with all of these arcs. So we'll just hover over this face here until we get close enough to this circle for it to be used. So we'll click that, and there we go. We'll use another replicate. We'll use another replicate in order to replicate this instance, and find a match in this. Or actually, we might be able to match. No, yeah, we'll just go ahead. We could also just do. You know what, I'm not entirely sure exactly how to do that. So we'll just go with, we'll stick with this. We'll just click this face, and that's going to give us a whole bunch of them. We can just go back and delete them all, right? We'll select them all, just by selecting them, and then press backspace. And that's a pretty quick way to do it, pretty painless way to do it. And there we go. So now if we go ahead and check our reference, and we made this from scratch. Are you guys proud of yourselves? I'm proud of yourselves also. But yeah, so we made this from scratch, right? So if we go ahead and look at the practice assembly, right? This isn't constrained at all, but this is sort of what it would look like. If we go to our assembled reference, we can also see that this is what it looks like, right? So we got it pretty bang on with our own parts. We didn't even use the ones that were given to us, which I think is really, really, really good. And this is basically what you do for CAD, right? Again, the design is not in the CAD, it's in your head, and you translate it onto the CAD using the skills that we're developing now. So some of those skills are getting stuff online that you would actually buy and use, and modifying them, right? Like cutting them down like you would with a radial arm saw or a bandsaw or something, and then putting bolts through them and tightening those bolts by literally just mating them together in the CAD. And if we go here, we can see we have some exploded views set up. And I won't get too much into how you make exploded views, but just know that exploded views are pretty cool, right? And you can just basically, if you go ahead and make a new exploded view, actually, I will get into how you make them, just because, yeah. So you click Add Exploded View, right? And it says you're editing it up here. You'll click the part you want to move, part you want to explode, and you'll move it out. And if you want, you can add other parts with that same transformation, and they will move as such, right? And then you can also click all these parts. And actually, you know what? Let's make them go a little bit farther back. We'll make them go -5 inches. So that's back 5 inches. But that seems pretty reasonable. And now we'll go ahead and move all these nuts as well. Move it out to here. Click this one, this one, this one, and this one. We'll say OK to that. And then we'll also move this gusset out like that. And we'll move this gusset out like that. And that's going to go ahead and show us, right, how you would assemble this, which is holding this joint together and then putting all these things together. And we'll rename this explode. We'll call it video demo explode. All right. And you can see here, if we click done, it'll just go back. So we didn't change anything about the CAD. We just added an exploded view. And exploded views will go ahead and ignore all mates that you have currently. It's a pretty handy tool, especially if you're making drawings or you want to show somebody how to assemble something, and it's pretty quick and easy to do. So we'll close this dialog window here, and we can take a look at this part that we made. We could also do it to the one that we have here, right? We do the same thing. And if we go ahead and look at our reference drawing, which is one that we made with the exploded view, we have a drawing of this, which we can use as a reference when manufacturing these things. Right, so when manufacturing these things, we have this. So we have an exploded view, and then we have different views of it when it's not exploded, right? And this wasn't made automatically. I made this earlier from this reference drawing, but it literally just entails adding a view here, then selecting the assembly that you want to insert as a view, and then choosing the view angle, so that's one of these, and then just dragging it and dropping it in there. And then you can add different things like notes or datums or dimensions like that. But yeah, so getting back to our presentation, right? Concluding this. Okay, how does this make us feel? No, what did we learn here, right? What did we learn? And you're gonna have to practice this a lot, right? Putting in time, in order to have the least disconnect between what's in your head and what's in the CAD. But what we learned is sort of how you can make things practically, right? That you can actually buy and actually manufacture, so that you can make CAD that you could actually make. Because that is the aim of CAD. It's to sort of test things that you're actually going to wind up making. I mean, robotics teams got on for a pretty long time without any sort of CAD, in the early days of FIRST. But their designs couldn't be as fleshed out just because they didn't really have, a huge vision of what they were doing. Or maybe one person did, but like the chief designer maybe, but not everybody else on the team knew it. And so it was harder to communicate and harder to sort of show. And so collaborations really, which are the source of many good designs, weren't as possible. So yeah, a good knowledge of assemblies is super important because then you can make CAD that you can actually build in real life. And so that's sort of what we learned today. Next time we'll get into a more complicated assembly, but it's going to be basically the same things that we just did here, but it's going to be a little bit more complex. So yeah. After that will be our last lesson in the instructional phase, and then the next 3 lessons after that will be making projects. And those projects are going to increase in difficulty, or not difficulty, but at least some complexity, right? You'll have more independence to do them as we go. And in between each project video, we'll have a video of me going over the project that I made for that task, and sort of doing a design review of it, right? I'll try not to make it perfect. It might be hard to not make it perfect, but I'll try. And then I can have a design review and point out some flaws in the design. So yeah. So next time we'll get into some more complicated assemblies, but just try to keep this in mind and practice it a little bit, because practice is the best way to learn these things. But when you're doing CAD, this is most of what you're going to be doing, right? Like I said before. So yeah, as always, if you have any questions, please leave them in the comments or send me an email. I would love to answer them, and I will try my best to answer them if I'm free. But yeah, thank you so much for watching, and I will see you all next time.